Okay, here's an example of finding the vertex and graphing when we started with an equation of a function in standard form. And I wrote a few things down here that might be helpful. In other words, here's our example. We're going to try to graph this guy over here. F of x equals x squared minus 2x minus 3, or same thing, y equals x squared minus 2x minus 3. So this is our rule. And we have other ways of writing the pair of numbers that belong to the function. Now remember, the function is a set of ordered pairs, so the point xy belongs to the function. In this case, we could say it's x f of x, because we have a rule to find the value of the function. And in this case, we actually can write down the rule, x squared minus 2x minus 3. And if we know what the x is, we can find out what the y is. And remember, this is like the input, and this whole thing is the output. In other words, if I take the input and I put it into this rule or algorithm, various operations, I'm going to get the output. Input, output, x, y, x, f of x, domain function, range function, horizontal component on an axis, vertical component. So there's all kinds of ways to name these things. In different cases, they will be more appropriate. Now remember, our rule, our function is given by x squared minus 2x minus 3. This means f of something means something squared minus 2 times that something minus 3. So we're going to put different values in, different inputs, and we'll get different outputs. Okay? Now, we want to find the vertex, so we know the vertex is given by this real nice equation, x equals negative b all over 2a. And we'll actually derive this. We'll actually show where this comes from when we take calculus. All right, so this is very easy to derive when you know calculus. And we want to identify our letters. So in standard form, it's ax squared minus bx, ax squared plus bx minus c. So in this case, the a is 1, the b is negative 2, and the c is negative 3. So we can identify those. So when we put this into our equation to find out what b is, that's going to be negative, and I'll leave a little parentheses, and that's going to be all over 2 times a. And what's my b? Negative 2. So now I've got double negatives, a negative in the formula and a negative in the data. And a is 1. That's just going to be negative times a negative is positive 2 over 2. So that's going to be 1. So what does that mean? That means that my vertex has an x value of 1. So I found that by this nice formula. Okay, so now how do I find the y? Well, I can find the y. I can just put it into this function, into the formula of the function. Okay, this is the x, this is the input. This is how I find the output. So this when my input is 1, this is how I find my output. So I can write y or f of x. In this case, I just would write y equals something squared, right, minus 2 times something, minus 3. And what's that something going to be? Well, in this case, it's going to be 1. And that's going to be, what's 1 squared? 1 minus 2 minus 3, or 1 minus 5, which is a 1, and a negative 5 is a negative 4. So that means that the y value will be negative 4. That's all there is to it. Now we can look at our vertex, and we know that if we look at the vertex, we can tell right away that the axis of symmetry, we've talked about this before when we were talking about parabolas, the axis of symmetry. And sometimes I just call this the AOS. All right, the axis of symmetry is just x equals 1, the x coordinate of the vertex. And just put an equal sign there, x equals 1. All right. Now, does this have a maximum or a minimum? Well, we can tell by looking at the a, that's whatever's in front of the x. If the a is positive, my parabola will be shaped like a U or an N, a U. So if a is positive, greater than 0. My parabola is shaped like a U, and I have a minimum value. That means it goes up and up and up, but it has a minimum value. It only is going to go so low. If a is negative, less than 0, negative starts with n, and my parabola will be shaped like an n. And I'll have a maximum value. That's easy to see. N for negative, and U if it's not negative. U has a minimum, N has a maximum. So in this case, since my parabola is shaped like a U because A is positive, I have a minimum value. So my minimum, and that's just the Y value. That's just negative 4. Now we could say Y equals negative 4, but we wouldn't want to be confused with a line. The axis of symmetry is a line. It's a vertical line, x equals 1, but the minimum value is just a number, negative 4. But if you said Y equals negative 4, in the context, we would know what you're talking about. So what can we graph so far? Okay. Now usually the graph paper we've been dealing with, it goes for 12 by 12s. So I gave you some 16 by 16s, and I'll put these as a PDF on my classroom site. And what I did was I extended these because on some of the problems you may have to go to 9 either way. So you can just, if you have any kind of graph like this, you don't have to like rescale it. You can just extend the lines a little bit. So I just showed with a ruler, I extended the horizontal and the vertical axis, and I kind of eyed these distances. And I put a, where I thought 9 and 10 would be in both directions. So just do something like this if you run off it and you're still close. If it's too far off, you may have to change the scale. All right, so let's find our vertex first, and our vertex was 1, negative 4. So out 1, down 4. So there's my vertex. And I can label that. It's always nice to label that. And I know my axis of symmetry is a vertical line, x equals 1. And we usually use a dashed line for that. So that's what we've got. And we know it's going to be shaped like a U, so it's going to go up. That's why I drew the axis of symmetry there. Now, how about the Y-intercept? Well, the Y-intercept, remember where it crosses the axis, and we've talked about this before when we did lines. You know, we found when we were graphing lines, we found the zeros when x equals 0. And I think you remember doing something like this, I hope. We would draw lines, we would x and y, and we would try our intercepts. In other words, the Y-intercept is when x is 0, the x-intercept is when y is 0. And you can see this on the graph. Any point on this y-axis, the x value is 0. 0, 0, 0, 1, 0, 2, 0, 3, horizontal 0, vertical, whatever. So the y-intercept will be when x is 0. Will be the point, x is 0, and what's y? Well, this is pretty easy in standard form, because if you look at standard form over here, and you put 0 in, any of these, if I put 0 in for x, x is 0, what's y going to be? Well, y will be 0 squared minus 2 times 0 minus 3. Pretty easy, right? Because 0 and 0 will just go away, so it's just negative 3. So that's going to be 0, negative 3. So that's my y-intercept, 0, negative 3. So I could put this on my graph now. Zero, negative 3, and there's my y-intercept. And I can label that. Now, since I have an axis of symmetry, I know that if I've got a point that's 1 unit to the left of the axis of symmetry, I've got a point that's 1 unit to the right, so I have another point by symmetry. So now I've got 3 points for the price of 2. It's almost like a twofer. Okay? 2 for 1. Okay. And this is on the list of things you had to do. That's what you had to find. Remember the homework problem asked you to find all these different things. Okay, so we've got the vertex, the axis of symmetry, okay, the maximum, actually the minimum value, the y-intercept. Now the x-intercepts. How are we going to find the x-intercepts? Well, remember, the y-intercept is when x is 0. I'm sorry, the y-intercept is when x is 0. So the x-intercept is when y is 0. So I go back up here and I look at this again. And when y is 0, that means, so what is x when y is 0? Put this down. X squared minus 2x minus 3. So what's x when y is 0? So when y is 0, what's x? And we could draw it like this. When y is 0, what's x? Okay, so that means this is going to be 0. All right, so how do we figure out what x is when that's 0? Oh, pardon me, let's bring that up a little bit. Okay. So how are we going to find x when this is 0? Well, we'll just set it equal to 0. And what have we got? A nice quadratic equation. X squared minus 2x minus 3, and I'll set that equal to 0. Okay? Now how do we solve that? Well, we have to factor x. And remember, we analyze our signs. This tells me that these signs are different. This tells me the sign of the larger is a negative, so I always put the larger on the left just to be consistent. So signs are different. Negative times a positive is a negative. And I need two numbers that multiply to give 3. And since the signs are different, their difference is 2. So they differ by 2. That would be 3 and 1. And then I can solve both these equations. X minus 3 equals 0. That means that x equals 3. Or x plus 1 equals 0. That means that x equals negative 1. And those are my x-intercepts. And remember, the y is 0. So in this case, x is 3, or x is negative 1. So those are your x-intercepts. So now we can plot those points and see what we got. And those are my x-intercepts. So actually we have 2 of them. So I've got 3, 0. Let's go over here. 3, 0, and negative 1, 0. And you can see they're symmetrical to the axis of symmetry, and now you got your points. And now you can connect that with a smooth curve, and then you'll be in business. And usually I'll try to do pencil so I can kind of get an idea of what it looks like and fill it in a little darker, and then if I mess up I can erase it. Don't want to do these in ink if you can help it. You could put your key points down in ink, that's all right, but you want to make sure that you get a nice smooth curve, and there's your parabola. Okay? Now we'll talk about domain and range in the next video because this is getting a little bit long. Okay, so you can always go back and review that, but that's the main idea.